if you remember the other day, we ended up here, we were talking about parametric equations. And this says find parametric equations for the equation y equals x squared minus 4. All you do is you do a little substitution. So you let t equal something. And what I would do is just let t equal x. Or not t equal something. You should let x equal t. I'm sorry. So I'm going to say let x equals t. And that's one parametric equation. And your other equation, you just take t and you plug it in there. So y would be what? Y would be, plug t in there. T squared minus 4. Now I could have let x be other things, or I could have let y be, or I could have let y equal to t, but then it would be more ugly if I would have wanted to make this so into a parametric equation. So if I plug these into my calculator and I were to graph this, I would get a sideways, or no, a right side up graph. If I graph this in parametric mode, I would get something that just looks like that. Okay? Is that hard? You need me to show you on the calculator how to do that? Okay? You would just plug it in and it would make trouble. Okay? And then this thing, it says find parametric equations for this ellipse. And what you do here is, first I would sketch a picture of it. This is an ellipse, and it has, since there's a 1 underneath here, right, it would go out how far? To 1, right? And it would go over to -1, and then it would go up to 0, 3, right? Because that's A over here, right? And that's B. And then it would go down here to 0, -3. So if I were to sketch that ellipse with my ellipse drawing tool, let's see if I can try to draw an ellipse in there. Ooh. I'm going to have to make it fatter. That's no, too big, too short. Let's see if I can figure that out. What if I, okay. So now if I grab this and drag it to over here, kind of like that. That looks pretty good. You get the idea, right? So that's that ellipse. And now you want to make parametric equations. So this is kind of weird. You wouldn't know how to do this unless someone told you how to do it. So what you have to do is, if you want to, and it'll say start it here and make it rotate in this direction, or it would say start it here and make it rotate in this direction, or it might say start here and make it go this way. Because when you are doing a parametric equation, t is the thing that you plug in first, okay? So if I want to start like here at 0, 3, I want y to be what when I start? 3. And one way I could do that is by letting y be 3 times the cosine of t. And the reason for that is, what's the cosine of, if I start at t equals 0, what's the cosine of 0? 1. And 3 times 1 would give me a y value of 3. You understand that? Okay? And then x would be, I want x to start off at 0, but I want x to go out only till 1, okay, not until 3. So as this angle goes from 0 to 90 degrees, because this, from 0 to 90 degrees, I want the x value to go from 0 up to 1, right? What's the cosine, excuse me, what's the sine of 90 degrees? Sine of 90 degrees would be 1, right? And the sine of 0 degrees, or 0 radians, is 0. So if I let x equal sine of t, then I am guessing that this number will start at 3, and since the cosine of 0, right, excuse me, the cosine of 90, or pi over 2, is 0, then this number will go to 0, which it's supposed to. So watch, let me just show you when I plug into my calculator, because I know you want to see that. So, how do I do this? Can I minimize this? Let me minimize this. Let me get rid of this. Let me get this. Let me get rid of this. Let me get my calculator. What's it? So if I go, first I want to make sure that I'm in mode parametric, okay? Now I got to go down to parametric. And the other thing I want to be is, whoops, oh, shoot. I'm in this program that I made the other day. Just go, sorry, mode, I want to be in parametric. Am I within the program? I don't think so. Let's go to parametric mode. Okay? Make sure you're in there. Make sure also that you're in radians. And simultaneous mode, that doesn't really matter at this point since you're only graphing one parametric equation. But, and then if I go to y equals, and oh, I did it already. No, that I have y equals 3 cosine t and x equals sine of t. See that? And I want to set up, when I set up my window, okay, I set my t's from 0 to 2 pi because I want to see what happens as I go around the circle. Done? And then I want a step, I put in a step 0.01 here. And the x min, I don't know, this is set from previous problem. So I want to set that, since I know that x only goes from -1 to 1, let's set that from -2 up to 2. And since I know, so I can see my whole graph, and since I know that y min goes from -3, or y goes from -3 to 3, I'm going to set that to 4, just so I can see everything. 4, 4, 4, 4, up to, can I just hit clear there? Oh, that's better. Up to 4, right? And then if I hit graph, my axes are off. So, because I turned them off for when I was teaching kids how to do the program. But you can see that it generates this ellipse. And I think I have a zoom square on there too. That's why it looks like that. So a couple things to make it look more like ellipse. If I went zoom 6, which is a standard viewing window, then you'd see that it looks more like that ellipse. And if I go into second format, axes on, okay, and you'll see that it actually goes through those points that I wanted it to go. Okay? There it is. Get it? And notice that it starts up here and goes this way. What if I wanted it started up here? What should I let over here? What should x be? X would be what? I want x to be 1 at the very, when theta is 0. So how would I do that? Cosine, right? So if I want to start my graph here, you would say x equals cosine of t, or something like that, right? And then y would be sine of t, because as I progress to 90 degrees, that one would probably go this way, okay? And you'll see some problems like that on your own, okay? Okay, the end.